All righty. We are going to start on page 7 for today. Okay. We're not graphing yet, but I do want to talk about, as we're talking about evaluating, I want to talk about ways that we can use evaluating as a tool to be able to find other stuff that we're interested in. And one of those things that we'll be interested in here shortly are key features of graphs, right? We're going to start by talking about evaluating as a tool to be able to find a y-intercept. So we talked about how tables are great when we're looking at a function and we're not maybe quite sure what it's supposed to look like. Table of values is a good way to get a quick idea of a rough sketch of our graph, okay? Depending on the values that we pick, we may get a terrific picture of our graph, we may get a mediocre picture of our graph, but it gives us a place to start. The other thing that we saw a lot yesterday, although we didn't call it out, and that we'll take a look at for today, the other thing that we can do with a table of values or with our evaluating as a tool is to be able to find a y-intercept. So even if I'm not looking at the actual graph of a function, this is something that we should be able to pick out from just the function itself. It's really nice if we have a table or a graph, but from just the function itself, we should be able to pick out a y-intercept without having to create a whole table or without having to sketch a graph. We'll do that by evaluating at f of 0. Why f of 0? Yeah, the y-intercept, our x coordinate is 0. So it's going to be 0 comma something. So if I want to know what the y-intercept is, I need to know f of 0. So that's what we're going to look at for today. That's our big idea for today. Now, for some functions, this is pretty easy and you'll get through them really quickly. For some of them, it's going to take a little bit more sort of computation to get there, but it's the same idea for everything that we're going to look at for today. So if I want the y-intercept for this first function, we are plugging in 0 for x. We are evaluating f of 0. What's nice about this first function when I evaluated f of 0? Yeah, these first couple of terms have x in them. So that's gone. And I'm adding and subtracting, so that's gone. And it's just -2. So my y-intercept here is -2. Our g of x function, our second function here, may be a little less nice. I'm going to actually have to do some work to get that y-intercept more so than I did with my first function, but that's okay. So this would be 100 times 2 to the 0 plus 3. So 100 times 2 cubed, that's 100 times 8. So we find our y-intercept to be 800.
Did you say b equals 800 or did you say y-intercept?
I would say my y-intercept. So I'm glad you asked that question because when we talk about lines, right, y equals mx plus b is our slope-intercept form, b is the y-intercept. But depending on the function that I'm looking at, like my quadratic right here, this is my y-intercept, that -2 at the end, but we actually don't call that b, right? We call that c. So label it as your y-intercept for me. Or if you wanted to tell me f of 0, in this case, f of 0 equals 800, that would be okay too. But depending on the function, we might use a different sort of letter to stand in for that. Number 3, I guess, f of t, same idea, a little bit less nice. This is another polynomial here. When I've got them in standard form, it's really easy to find that y-intercept. But this would be a quadratic in vertex form, so I've got to do a little work on this one. Again, we're just plugging in 0 for x. So this would be -3. When I square -3, I get 9. So we've got -16 times 9 plus 300. That would be -144 plus 300, which gives us a y-intercept or an f of 0 of 156. I want you to try the next 3 problems. So this guy, and this guy. Make sure you're careful with your signs. And check your work keys. Question for me so far? Okay. Let's take a look at the last couple. We've got an exponential function here, a square root function, a rational function, a constant function. So for most of our last examples, we're going to do the same thing that we did for the first few, which is plug in 0 for x, right? So for this guy here, if I plug in 0 for x, I've got -1 as my exponent. Remember, when I've got a negative exponent, I'm flipping that. We're taking the reciprocal. So this would be 1,000 times 4. And our y-intercept would be then 4,000. For h of x, we would have the square root of 16, right? 0 plus 16 is just 16 minus 12. So that's 4 minus 12. We get a y-intercept at -8. And then for our g of x, plugging in 0 for our x's here, we would get -2 over 20. If you're giving me a decimal as an answer, that's fine. Generally, if you were giving me a decimal, I want a minimum of 2 decimal places. There will be times when we'll need more decimal places, but for right now, minimum of 2 properly rounded decimal places. If you were giving me a fraction, that's fine too, but it needs to be reduced. So don't give me -2 over 20 because that's not reduced. I want -1 over 10, okay? Reduce. This last one here is what we call a constant function, right? H of x equals 7, okay? What that means, if we think about our graph, okay? If I were to sketch a graph off to the side, that means that we have, no matter what's going on, just a horizontal line at 7. That makes sense? Okay. This one seems a little hinky because there's nowhere to plug in an x, right? There's no, like, I can't plug in anything. It's just like y equals 7. Y is always 7. No matter what x is, y is 7. So what does that mean for our y-intercept? It's got to be 7, right? Sometimes this trips us up because there's nowhere to plug in x. This is the easiest one on the whole page because no matter what x is, y is 7. Turn the page for me. So with this idea in mind, I want to talk about a couple of sort of application problems here for y-intercepts, interpreting when my function is not just f of x equals h of x equals, but it's got a context, okay? So just a couple to talk about really quickly. For number one, we have a quadratic here. 9 times out of 10, if you're looking at an application of a quadratic, it's going to be some sort of projectile, something going up and coming down. In this case, it's a toy rocket we are launching. And its height, as a function of time since its launch, is represented here, okay? So I want you to find the y-intercept and then tell me what it means, okay? This is an easy one to find the y-intercept on. What is it? What's our y-intercept here? 32, right? This is a standard form polynomial. Those are nice for y-intercepts because that's 0, it's just 32. So 0 is just 32 here, or h of 0, I should say. So the y-intercept's 32. This one has a context, though. So I want to know, what does that 32 mean? What's it telling me? Mm-hmm.
The rocket starts at 32 feet above, or 32 units.
Yeah, I didn't give you a label here, right? And I like to use the word initial a lot when we talk about y-intercepts. The initial height of the rocket is 32, you said units, so I'll write units too. Yeah, I didn't specify if it was feet or inches or centimeters or miles. Okay, 32 something. Number 2, Anna's ordering food from an online delivery service. Her total delivery fee is given by this equation, where m is the number of miles away from the restaurant. Another easy one to find the y-intercept. What is the y-intercept here? 3, right? Easy to find it. What does it mean? Mm-hmm. Yeah, so we're getting, this is a delivery service, right? It's like a Uber Eats situation. And the charge is per mile plus some sort of flat fee is what we're seeing from our function here. This is our charge per mile, but it's always going to be at least $3. So let's say maybe the base charge for delivery is $3. And then number 3, again, this one, not terrible to find the y-intercept. Go ahead and find that y-intercept for me. What's your y-intercept here? If I plug in 0 for my variable, anything to the 0 power is just 1. So we would have 16,000 for our y-intercept. What does it mean?
Population 2020.
Yeah, make sure you're giving me both of those pieces, right? This is the only one where it's not like where we're starting, right? Here, the base charge for delivery, the initial height of our rocket. For this one, that time is, I guess, when we started keeping track of the population, but I have a very specific time for that. So the population in 2020 was 16,000. So everything we've looked at so far, I've asked you to find a y-intercept, and you can find one for me, right? It's been 7, or it's been 16,000, or it's been 1/10, negative 1/10. You've been able to find a value for that y-intercept, okay? That's not always going to be the case. So right now, actually, before we turn the page, there's more space down here, where you've got some space on your paper. I want you to think about a function, right? You don't have to write out the function. I want you to sketch a little picture for me that would not cross the y-axis. Take a minute, sketch me something that is not going to touch or cross the y-axis. Something that does not touch or cross the y-axis. I saw a lot of vertical lines as I walked around. Absolutely right. A vertical line that is not the y-axis itself isn't going to have a y-intercept. It's not going to cross or touch the y-axis. I also saw, as I walked around, something that looked kind of like this. And I can't remember if it was like this or if it was oriented the other way. This looked to me like it would be what we'll see is a logarithmic function. Those also will not necessarily have a y-intercept depending on where their asymptote is. We'll talk about this more in depth later this year, but logarithmic functions are the inverse of exponential functions. Exponential functions, we know, look something like this, or maybe something like this, and they have horizontal asymptotes. Logarithmic functions have a vertical asymptote, meaning there is a place beyond which they will not cross, right? That sort of invisible, like force field line in there. I also saw quite a few parabolas. And I saw quite a few parabolas that were off to one side, right? Something like this. What do we know about these arrows for my parabola on the end? Some of them were facing up, some of them were facing down, but what do these arrows tell me? It keeps going, right? Now, here's the thing. They grow vertically. Either they're going to go up or down. They grow vertically much faster than they grow horizontally, but they don't flatten out, right? Our parabola is going to keep going. And it's going to take a long time to hit that y-axis, but it is going to hit that y-axis, right? On both ends, we're still growing out. It's a lot of parabolas. Parabolas are going to have a y-intercept. They will have a y-intercept. Always, all the time. They do not always have x-intercepts, but they will always have a y-intercept. And if you turn to the next page for me, I want to talk about how do we handle algebraically functions that don't have a y-intercept, like a logarithmic function, or like we'll talk about rational functions here in just a second, or your vertical functions, your vertical lines that several of you drew for me. How do we handle something like that algebraically? What does it look like when we're not going to have a y-intercept? So the two things that we're going to look out for, okay, are division by zero. Okay, which we would get if we tried to find the slope of a vertical line anyway. Okay, and then we'll see some rational functions where the problem is that if I plug in 0 for x, I'm dividing by 0. We'll see a couple examples like that. The other issue that we're going to have, no one gave me one of these, is the square root of a negative. Okay, and we talked about square roots of a negative, I think, for just a hot second earlier this week. But if I got something like the square root of -3, right? If I were plugging things into an XY table, we did this the other day, and we ended up with something like the square root of -3. we said we can't actually put anything in that y column because it's not a real value. Okay, so our square root functions, if you take a look over here with me for just a second, our square root functions, because they have that sort of endpoint, kind of unique. Not a lot of the functions that we talk about have that endpoint like square root functions do. Depending on where that endpoint is, we may have a y-intercept or we may not. Okay, that's the other thing that we'll watch out for. Linear functions, quadratic functions, other polynomials, exponential functions will always have a y-intercept. They're always going to have a y-intercept because we don't need to exclude any values from their domains. Their inputs can be anything from negative infinity to positive infinity. Or if we write that other notation here, we talked about both the other day, but their domains are all real numbers. Okay? 0 is a real number, so it can be part of the domain. That means it's going to have a y-intercept. It means we can plug in 0 and get a real number out. So let's take a look at some examples where maybe we don't get a y-intercept. So for our first function here, f of x is a rational function. A polynomial on top of another polynomial, that's a rational function. If I plug in 0 here, on the top, this is 0 plus 0 plus 8. So on the top, I get 8. On the bottom, I would get 0 minus 0, which is 0. What do we say about dividing by 0? It's, say it again. Other way. If 0's on the bottom, undefined, right? Okay? That's bad news bears. We don't like that. This is undefined. That means we have no y-intercepts here. So there's something weird that happens on the graph at that spot. Maybe a hole, maybe an asymptote. Our next problem, another rational function. If I plug in 0 for all my values of x, on the top, 0 plus 5 is 5. On the bottom, if I just had these guys, we'd be okay. Because I have negative 3 times 1, but I'm multiplying by 0 in front there. So the whole bottom is again just going to be 0. Okay. This is undefined, so we have no y-intercept. These two right here, the two functions remaining in that left-hand column, also rational functions. I want you to try and find that y-intercept for me for those. This guy and this guy. Did you get y-intercepts? Yeah, so just because it's a rational function doesn't mean it's not going to have a y-intercept. Plenty of them don't have y-intercepts. Plenty of them do have y-intercepts. This guy would be, if I plug in 0 for all my x's, This would be 0 minus 2, so negative 2 over 0 minus 0 plus 7. Negative 2 over 7. Maybe not the prettiest y-intercept in the world, but it's a y-intercept. And then down here, if I plug in 0 for x, this would be 0 plus 18 is 18 over 0, 0, negative 18. So we would get negative 1 here. The last two, we've got some square root functions. Okay. So we're going to plug in 0. For this guy, square root of 2 times 0 minus 10. That's 0. So we have the square root of negative 10. Square root of a negative, not a real number, so we won't see a y-intercept on this guy. Since we got a non-real number, that means we're not on a coordinate plane going to see a place where this graph touches or crosses. This function touches or crosses the y-axis. And then our last one down here, same idea, plug in 0 for x. This would give me the square root of 9 plus 4. We could do the square root of 9. Even if this wasn't a nice number, that would be okay. If it were the square root of 7 instead, that would still be okay. It doesn't have to be a nice square root, as long as it's not negative. Does that difference make sense? Okay, so for this one, it is a nice number. The only thing I have to watch out for is the square root of a negative. Doesn't have to be a perfect square, as long as it's not negative. I want you to try now the extension problems at the bottom. So write me a function that has a y-intercept of 8, and then write me a function that does not have a y-intercept. Your functions can be as simple or as complicated as you would like to make them. Saw a lot of standard form polynomials for this guy. Saw a lot of just y equals 8, which is also fine. I saw some square roots, some other funkier stuff for no y-intercept. I also saw somebody gave me, again, a line, but one that's an x equals line, right? A vertical line that's going to be off the y-axis. That works. Again, I saw some square roots. When I walked around, I saw one that I think was square root of x minus 9, if I'm remembering. You could have also had a rational function 1 over x. That would be undefined if I plugged in 0 for x there. So that one would also not have a y-intercept. Tons and tons and tons of options. I saw some linear stuff, some quadratic stuff here, some other polynomial stuff for this top one. Okay, a lot of good options. Questions for me for today? All right. You do have a very short assignment on Delta Math for today.